Hi everyone, welcome to my YouTube channel Take Data Engineer. So in this video we will see the data structure algorithm introductions. Apart from that we will see the basic data structure and that implementation that to be implemented in Python. Okay, so basically in this series we will cover whatever the DSA data structure algorithm implementation we will do. We will choose the Python. Okay, so let us start with the introduction part. So DSA stands for data structure and algorithm, and that is the fundamental concept in computer science that involve organizing and manipulating the data efficiently. Okay, so how we are organizing the data in real world and manipulating the data, accessing the data, sorting the data. So everything should be done by the help of algorithm and by choosing the right data structure. Okay, so DSA combine two things: data structure and algorithm. So data structure are way to store and organize data so that it can be accessed and modified efficiently. Okay, so if you are storing any data in any storage system or anywhere, so like which data structure you will choose, either you'll choose array for that or list for that, or you will choose tuple for that, or you will store your data in the way of dictionary so that it will be easier to access. So based on your use cases and your scenario, you have to choose the right data structure so that it should be accessed and modified efficiently. So that's why data structure is important. Then algorithm. Algorithm are nothing but it's a step by step procedure to solve any problem. Okay, so basically for solving any problem we follow some steps. Okay, so that step is nothing but the algorithm. Okay, so for solving any algorithm we required some time, some space, so that is called time complexity and space complexity. Okay, so there might be the scenario you are solving in the worst case or average case or best case. So that all we will see, like every notation, big O notation, theta notation or omega notations. So the which algorithm takes what time in which scenario, so that all these things we will see in this video. Okay, so why DSA? So DSA is crucial because it directly impacts the performance, scalability and efficiency of software. Okay, so definitely, so which data structure you are using, obviously it will help to increase or decrease the performance of your system. Okay, so in real world software engineering, choosing the right data structure and algorithm can make a significant difference in time and space efficiency. So it does matter, like what is your data volume, what type of data you have. So based on that you have to choose the basic data structures, and that then according to that you have to choose the your algorithm also. Okay, so apart from that we will see why DSA is important in real world of software engineering. Okay, so first is the optimization. So choosing the right data structure and algorithm help optimize the performance of your program. So whether it is related to processing speed, either time complexity or memory uses, like a space complexity. So let us see example. Using a hash table for lookup can provide constant time access, where using a linked list might result in slower search. So if you are using a hash or linked list for a same case, then in that case your hash table will take lesser time compared to linked list. So that way it will help if you are choosing the right data structure and algorithm, that will help in optimizing your program. Okay, then efficiency. So DSA help ensure that software can scale and handle increased load. So whenever there is a scale happen to your system, so it your data structure should handle the scale system. Like if data volume will increase, so it should handle. Okay, a more multiple request will come, so it should handle that. Okay, so then apart from efficiency, problem solving. So many real world problem are inherently mathematical or logical. So algorithm allow developer to solve this problem in most efficient possible way, whether it is optimizing a path in a GPS system. So GPS system, how we will use the graph algorithm for that, searching a database or managing a memory in a device. So this all real world problem are inherently mathematical or logical problem. Okay, so we, by the help of that, we will solve all this real world problem. Okay. In case of interview or hiring, yeah, obviously the data structure and algorithm, that is important. If you are attending any interview, so that is required for that, that is also important. Then complexity management. So as system grow larger, the complexity of managing data increases. Okay, so if you are using a, if you have a good grasp of DSA, so you'll handle the complexity of software efficiently. Then you'll, that leads to the better maintainability and extensibility of your system also. Okay, so these are the benefits why we are using the, why the DSA is important. Okay. Then apart from that, we will see the type of data structure. So basically there are two types of data structure. One is the primitive data, other is the non-primitive. So primitive data structure basically are the, these are the basic data type like integer, float, character, boolean. Okay, so that can be directly used by a computer. Okay, so this have this example. And then non-primitive data structure. So non-primitive data structure are the complex structure that are more complex, that allow for organization of large amount of data. Okay, so non-primitive data structure is also divided into two part. One is the linear data structure and other is the non-linear data structure. So in case of linear, we have array. So array is nothing but a collection of element identified by index or key. Okay, so it is a homogeneous collection of data, array. Then linked list we have. Then we have a stack, which basically for the leaf order, last in first out, then queue. So this all we will see in details. Then if you're talking about the non-linear data structure, we have tree like binary tree, evil tree, red black tree, b tree, that we will see. Then graph we have, then we have heap. Okay, heap we have max heap, min heap. So these are the non-linear data structure. Okay, so we have data structure two type, primitive, non-primitive. And non-primitive also we have two type, linear data structure and non-linear data structure. So these are the type we have. Okay, then coming back to the algorithm, we have different types of algorithm also. First is the sorting algorithm. So sorting algorithms covers bubble sort, merge sort, quick sort, insert sort, insertion sort. So these are the sorting algorithm we have. We have many algorithm name that is missing here, but these are the algorithm comes under sorting algorithm. Then we have searching algorithm. So searching we have two, linear search and binary search. Okay, so this time complexity example and implementation in Python we will see in the upcoming video. So this is the introduction part, so we are not covering that. Then coming to the, apart from sorting searching algorithm, we have greedy algorithm. So a greedy algorithm makes locally optimal choose at each step. Okay, so that is greedy about the, so whenever it is it has to choose the decision, it will not choose, it will just it will be greedy at the that instant, like it will choose always the locally optimal choice. Okay, so we have discussed, we have the castra algorithm, and we have Kruskal or Prim's algorithm. Okay, for minimum spanning and sorted path. Then again come to the, we have dynamic programming. So this is DP is basically used to solve complex problem by breaking them into smaller sub problem, simpler sub problem. Okay, so dynamic, first we have to break down the bigger problem into a smaller problem. So these have like Fibonacci sequence or knapsack problem or LCS, longest common subsequence. So these are the problem which basically we will solve in case of dynamic programming. Then backtracking algorithm. So backtracking is the problem solving where solution is built incrementally and abandoned as soon as it determined that it cannot lead to a valid solution. Okay, so backtrack we will do once we will see that okay, at some point of time it is not doable or not built a solution, then we will abandon the uh, we want the steps and like get back to the previous step. Okay, like n-queen problem, sudoku solver, or substitute sum problem are the example of that. Then we have a divide and conquer. So this algorithm basically divide the problem into a smaller sub problem and solve them recursively. Okay, so these are merge sort, quick sort, binary search. These are the example of that. Then we have graph algorithm. So for solving the graph like BFS, DFS, we have the Castro algorithm, Plody-Warshall algorithm, all pair shortest path, and shortest path for weighted graph, non-weighted graph. So this all we will see in the later video. Then we have a string algorithm. Okay, so this algorithm focus on solving problem related to string or sequence of character like Rabin wrap or measuring the distance between two sequence. Okay, so these are the KMP problem, LD problem. This all we will see in the string algorithm. Okay, so time and space complexity we have already seen. Like time complexity refers to the amount of time an algorithm takes to complete based on size of the input. Okay, so it determines the size of the input also. Okay, so based on what input data, this will take time, that is called time complexity. And space complexity refers to the amount of memory an algorithm use relative to the input size. Okay, so everything is related to the input size. If it is taking what time or what space, that is called time complexity and space complexity. So it also are divided into three type like average case, best case, average case, and worst case. Okay, so we have big O, big omega, and big theta. Okay, so this implementation we will see. Then common notations we have like constant time, it will be big O1, big O n is the linear time, big O log n is the logarithm time, big O n square the quadratic time. Okay, so these are the introduction part of the DSA. Okay, so then other like basic data structure or advanced data structure like list, stack, queue, this all we will see in the later video. Okay, thank you, thanks for watching.